Section 4.3, Centralized Configuration Management with Spring Cloud Config Server. With environment variables, you can externalize your application's configuration and follow the 15-factor methodology. However, there are some issues they cannot handle. Configuration data is as important as the application code, so it should be handled with the same care and attention, starting from its persistence. Where should you store configuration data? Environment variables don't provide granular access control features. How can you control access to configuration data? Configuration data will evolve and require changes, just like application code. How should you keep track of the revisions to configuration data? How should you audit the configuration used in a release? After changing your configuration data, how can you make your application read it at runtime without requiring a full restart? When the number of application instances increases, it can be challenging to handle configuration in a distributed fashion for each instance. How can you overcome such challenges? Neither Spring Boot properties nor environment variables support configuration encryption, so you can't safely store passwords. How should you manage secrets? The Spring ecosystem offers many options to address those issues. We can categorize them into 3 groups. Configuration services. The Spring Cloud project provides modules you can use to run your own configuration services and configure your Spring Boot applications. Spring Cloud Alibaba provides a configuration service using Alibaba Knockos as the data store. Spring Cloud Config provides a configuration service backed by a pluggable data source, such as a Git repository, a data store, or HashiCorp Vault. Spring Cloud Console provides a configuration service using HashiCorp Console as the data store. Spring Cloud Vault provides a configuration service using HashiCorp Vault as the data store. Spring Cloud Zookeeper provides a configuration service using Apache Zookeeper as the data store. Cloud vendor services. If you run your applications on a platform provided by a cloud vendor, you might consider using one of their configuration services. Spring Cloud provides integration with the main cloud vendor configuration services that you can use to configure your Spring Boot applications. Spring Cloud AWS provides integration with AWS Parameter Store and AWS Secrets Manager. Spring Cloud Azure provides integration with Azure Key Vault. Spring Cloud GCP provides integration with GCP Secret Manager. Cloud Platform Services. When running your applications on a Kubernetes platform, you can seamlessly use config maps and secrets to configure Spring Boot. This section will show you how to set up a centralized configuration server with Spring Cloud Config that's responsible for delivering configuration data stored in a Git repository to all applications. Chapter 14 will cover more advanced configuration topics, including secrets management and Kubernetes features like config maps and secrets. Many of the features and patterns you'll use with Spring Cloud Config are easily applicable to the other solutions involving configuration services and cloud vendor services. Note: your choice of configuration service will depend on your infrastructure and requirements. For example, suppose you're running your workloads on Azure already, and you need a GUI to manage configuration data. In that case, it might make sense to use Azure Key Vault rather than running a configuration service yourself. If you want to version control your configuration data with Git, Spring Cloud Config or Kubernetes config maps and secrets would be a better choice. You might even compromise and use a managed Spring Cloud Config service offered by vendors like Azure or VMware Tanzu. The idea of centralized configuration is built around 2 main components. A data store for configuration data, providing persistence, versioning, and possibly access control. A server sitting on top of the data store to manage configuration data and serve it to multiple applications. Imagine having many applications deployed in different environments. A configuration server could manage configuration data for all of them from a centralized place, and that configuration data might be stored in different ways. For example, you could use a dedicated Git repository for storing non-sensitive data and use HashiCorp Vault to store your secrets. No matter how the data is stored, a configuration server will deliver it to different applications through a unified interface. Figure 4.7 shows how centralized configuration works.
Figure 4.7. A centralized configuration server manages external properties for many applications across all environments.
It's clear from Figure 4.7 that the configuration server becomes a backing service for all the applications, which means it's at risk of being a single point of failure. If it's suddenly unavailable, all the applications will probably fail to start up. This risk can be easily mitigated by scaling the config server, as you would with other applications requiring high availability. When using a configuration server, it's fundamental to deploy at least 2 replicas. Note: you can use a centralized configuration server for configuration data that doesn't depend on the specific infrastructure or deployment platform, such as credentials, feature flags, URLs to third-party services, thread pools, and timeouts. We'll use Spring Cloud Config Server to set up a centralized configuration server for the Polar Bookshop system. The project also provides a client library, Spring Cloud Config Client, that you can use to integrate Spring Boot applications with the config server. Let's start by defining a repository for storing configuration data. Section 4.3.1. Using Git to store your configuration data. The config server will be responsible for providing configuration data to Spring applications. Before setting that up, though, we need a way to store and keep track of that data. Spring Cloud Config Server integrates with many different back-end solutions to store configuration data. One of the most common choices is a Git repository. First, create a new config repo Git repository. For the final result, you can refer to chapter 04/04n/config repo. The repository can be local or remote, but for this example, I recommend initializing a remote one on GitHub, just like you did for the application repositories. I'm using main as the default branch name. Inside the config repo, you can store properties directly in Spring format as *.properties or *.yml files. Continuing with the catalog service example, let's define an external property for the welcome message. Navigate to the config repo folder and create a catalog service.yml file. Then define a value for the polar.greeting property used by the catalog service.
Listing 4.8. Defining a new message for when the config server is used.
Next, create a catalog service prod.yml file and define a different value for the polar.greeting property to be used only when the prod profile is active.
Listing 4.9. Defining a new message for when the prod profile is active.
Finally, commit and push your changes to the remote repository. How does Spring Cloud Config resolve the correct configuration data for each application? How should you organize the repository to host properties for multiple applications? The library relies on 3 parameters to identify which property file to use to configure a specific application. Application. The name of the application as defined by the spring.application.name property. Profile. One of the active profiles defined by the spring.profiles.active property. Label. A discriminator defined by the specific configuration data repository. In the case of Git, it can be a tag, a branch name, or a commit ID. It's useful for identifying a versioned set of config files. Depending on your needs, you can organize the folder structure using different combinations, such as these.
See this code.
For each application, you can either use property files named after the application itself and placed in the root folder, for example, /catalogservice.yml or /catalogserviceprod.yml, or use the default naming and put them in a subfolder named after the application, for example, /catalogservice/application.yml or /catalogservice/applicationprod.yml. You can also put application.yml or applicationprofile.yml files in the root folder to define default values for all applications. They can be used as a fallback whenever there is no more specific property source. Spring Cloud Config Server will always return the properties from the most specific path using the application name, active profiles, and Git labels. The label concept is particularly interesting when using Git as the backend for the config server. For example, you could create long-lived branches of your config repo for different environments or short-lived branches while testing specific features. Spring Cloud Config Server can use the label information to return the correct configuration data from the right Git branch, tag, or commit ID. Now that you have a Git repository in place for your configuration data, it's time to set up a config server to manage them. Section 4.3.2. Setting up a configuration server. Spring Cloud Config Server is a project that lets you set up a configuration server with minimal effort. It's a standard Spring Boot application with specific properties that enable the configuration server functionality and the Git repository as the configuration data backend. The Polar Bookshop system will use this server to provide configuration to the catalog service application. Figure 4.8 illustrates the architecture of the solution.
Figure 4.8. A centralized configuration server, backed by a Git repository, provides configuration to the catalog service application.
Now on to the code. Bootstrapping the project. The Polar Bookshop system needs a config service application to provide centralized configuration. You can initialize the project from Spring Initializer, start.spring.io, and store the result in a new config service Git repository. The parameters for the initialization are shown in Figure 4.9.
Figure 4.9. The parameters for initializing the config service project from Spring Initializer.
Tip: you may prefer to avoid manually generating the project through the Spring Initializer website. In the Begin folder for this chapter, you can find a curl command that you can run in a terminal window to download a zip file containing all the code you need to get started. In the generated build.gradle file, you can see how the management of Spring Cloud dependencies works differently than for Spring Boot. All Spring Cloud projects follow an independent release train that relies on a bill of materials, BOM, to manage all the dependencies. Spring Cloud release trains are named after a year, for example 2021, 0.3, rather than adopting a semantic version strategy. For example, the Spring Boot version is 2, 7.3.
Listing 4.10. The Gradle configuration for config service.
These are the main dependencies. Spring Cloud Config Server, org.springframework.cloud Spring Cloud Config Server, provides libraries and utilities to build a configuration server on top of Spring Web. Spring Boot Test, org.springframework.boot Spring Boot Starter Test, provides several libraries and utilities to test applications, including SpringTest, JUnit, AssertJ, and Mockito. It's automatically included in every Spring Boot project. Enabling the configuration server. Turning the project you initialized earlier into a functioning configuration server doesn't require too many steps. The only thing you need to do in Java is add the enable config server annotation on a configuration class, such as config service application.
Listing 4.11. Enabling configuration server in Spring Boot.
That was it on the Java side. Configuring the configuration server. The next step is configuring the behavior of the config server. Yes, that's right. Even a configuration server needs configuration. First of all, Spring Cloud Config Server runs on an embedded Tomcat server, so you can configure connection timeouts and thread pools as you did for catalog service. You previously initialized a Git repository to host configuration data, so you should now instruct Spring Cloud Config Server where to find it. You can do so in an application.yml file located in the src/main/resources path of your config service project. Rename the auto-generated application.properties file as application.yml. The spring.cloud.config.server.git.uri property should point to where you defined the config repo. If you followed along with what I did, it will be on GitHub, and the default branch will be called main. You can configure which branch the config server should consider by default by setting the spring.cloud.config.server.git.default label property. Remember that, when using Git repositories, the label concept is an abstraction over Git branches, tags, or commit IDs.
Listing 4.12. Configuring integration between config server and config repo.
Warning: the configuration I used for config service assumes the config repo is publicly available on GitHub. When you use private repositories, which is often true for real-world applications, you need to specify how to authenticate with the code repository provider by using additional configuration properties. For more information, refer to the official Spring Cloud Config documentation. See this link. I'll further discuss handling credentials in Chapter 14. Section 4.3.3. Making the configuration server resilient. The config service might become a single point of failure in your system. If all the applications rely on it to fetch configuration data, you need to ensure it's highly available. The first step toward that goal is deploying multiple instances of config service in a production environment. If one of them stops working for some reason, another replica can provide the required configuration. In Chapter 7, you'll learn more about scaling applications and how to make that work in Kubernetes. However, scaling the config service is not enough. Since it's using a remote Git repository as the configuration data backend, you'll need to make that interaction more resilient too. First, you can define a timeout to prevent the config server from waiting too long to establish a connection with the remote repository. You can do so with the spring.cloud.config.server.git.timeout property. Spring Cloud Config is implemented to clone the remote repository locally upon the first request for configuration data. I recommend using the spring.cloud.config server.git.cloneOnStart property so that the repo clone happens at startup. Even though it makes the startup phase a bit slower, it makes your deployment fail faster if there's any difficulty communicating with the remote repository, rather than waiting for the first request to find out that something is wrong. Also, it makes the first request from a client faster. The local copy of the repository improves the config server's fault tolerance because it ensures it can return configuration data to the client applications even if the communication with the remote repository is temporarily failing. For example, if GitHub is down or there's a problem with the network. However, if the config server hasn't cloned the repository locally yet, there's no fallback in place. That's why it's better to fail fast at startup and investigate the issue right away. When a local copy of the repository is created successfully, there's a chance the local repo may get changed independently of the remote repo. You can ensure your config server always uses the same data that's defined in the remote repository by setting the spring.cloud.config.server.git.force pull property so that a fresh copy is pulled whenever the local copy is corrupted, and any local changes are discarded. By default, the local repository is cloned in a folder with a random name. If needed, you can control where it is cloned through the spring.cloud.config.server.git.basetier property. For config service, we'll rely on the default behavior. You can update the application.yml file for the config service application as follows and make it more resilient to faults affecting interactions with the code repository service, in this case GitHub.
Listing 4.13, making config service more resilient.
In the next section, we'll verify that config service is working correctly. Section 4.3.4, Understanding the Configuration Server, REST API. Spring Cloud Config Server works seamlessly with Spring Boot applications, providing properties in their native formats through a REST API. You can try it out fairly easily. Build and run config service, /gradle w bootrun, open a terminal window, and make an HTTP GET request to /catalog service /default.
See this code?
The result is the configuration that's returned when no Spring profile is active. You can try fetching the configuration for the scenario where the prod profile is active as follows.
See this code?
As shown in Figure 4.10, the result is the configuration defined for the catalog service application in catalogservice.yml and catalogserviceprod.yml, where the latter takes precedence over the former because the prod profile is specified.
Figure 4.10. The configuration server exposes a REST API to fetch configuration data based on the application name, profile, and label. This image shows the result for the /catalog service /prod endpoint.
When you are done testing the application, stop its execution with Ctrl-C. Spring Cloud Config Server exposes properties through a series of endpoints using different combinations of the application, profile, and label parameters.
See this code?
You won't need to call these endpoints from your application when using Spring Cloud Config Client. It does that for you. But it's useful to know how the server exposes configuration data. A configuration server built with Spring Cloud Config Server exposes a standard REST API that any application can access over a network. You can use the same server for applications built with other languages and frameworks and use the REST API directly. In Chapter 14, I'll address more aspects of how to handle configuration. For example, Spring Cloud Config has a few features for encrypting properties containing secrets before storing them in a Git repository. Also, multiple backend solutions can be used as configuration data repositories, meaning that you could save all the non-sensitive properties in Git and use HashiCorp Vault to store secrets. Furthermore, the REST API itself should be protected, and I'll talk about that as well. I will address all those critical aspects from a security point of view, considering these issues is necessary before deploying to production. For now, let's complete our solution and update catalog service to integrate with the config service application.